Okay, following the same framework as we did in NFAs, now our next step is to define the transition function as it works on strings, and here things get more tedious. So the problem, of course, is that the transition function, when we give it a state Q and a character A, what we get is a set of states. But now we have the extra headache of epsilon transitions. Okay, so we're going to define the function delta star, which would be all the state that one can reach from Q for a string W. Okay. And for this, we need to speak about this epsilon closure. So epsilon reach is going to be a function that for every state tell us all the state that you can reach from these states using only epsilon transitions, right? So in this example, from S with epsilon transition, so epsilon reach of S, for example, in this case is going to be S. You can always stay where you are, right? And you can also travel to D, right? But once you're at D, you can, of course, epsilon transition to A, right? So it's going to the SDA. And that's it, right? Now let's do the epsilon reach of D. So again, it's going to be the state itself, D, and then A. Okay. A, the epsilon reach of B is going to be just B, right? And similarly, the epsilon reach of A, I guess I should have done A first, doesn't really matter, is A. Epsilon reach of C, that might be a bit more interesting. This is going to be what? C itself, of course. Then you can travel to D. If you can travel to D with epsilon transition, you immediately get all the epsilon transition that it has. So A, of course, also. And you can also, from C, you can also traverse to epsilon transition to G. And that's it, right? So this is C. Okay, so we did SDBA, C. I guess we need to do E. Okay, epsilon reach of E is, of course, not very interesting. It's just E itself. And epsilon reach of F is going to be F, of course, but also you can traverse to E. And finally, epsilon reach of G is just going to be G itself. Okay, so this is the epsilon reach function. It's just the epsilon closure. It essentially says if you're in this location, what are the locations that you can arrive to just using the epsilon reach, the epsilon transition, sorry. Okay, now we're going to extend the epsilon reach function so that it works on a set of states. So given a set of states, the epsilon reach of the set of states is the union of all the epsilon reach of the element of the set. To remind you, an epsilon reach of a state always include the set itself. So the epsilon reach of X in particular include also X. Okay, so it's just the transitive closure of this epsilon transition relation. Well, it's not mathematically relation, the epsilon transition edges. Okay, and now we are ready to define the transition for strings. Confusingly, the definition is, of course, recursive. Great. So if the string is the empty string, then the transition of Q on the empty string is, of course, just the epsilon reach of Q, all the states you can arrive with string. And now, if the string is a single character, then here's what we do. We take this state Q, we compute its epsilon reach, Now for every state in its epsilon reach, we compute all the states that it can arrive to. This is delta star. Should be, I don't know why well, in fact, sorry. Here it's in fact what's written is correct. In the next one it's not. Okay, so we compute all the states that are reachable from Q, and then from each one of them we get the set of states that you can reach from P, and we take their union, right? So those, and now for the set of states, we compute the epsilon closure, we compute the epsilon reach, and those are all the states that you can reach from Q using a single character A, right? And the way to think about it is that you start from Q, you transition on any sequence of epsilon transitions, you get them to some state P, you traverse on the letter A to some other state, let's call it U, and then you traverse again with a sequence of epsilon transition. And you take the union of all those things, and this is going to be the transition for the letter A. Okay, so here this is pretty tedious, but it is what it is. Okay, and now we can define the recursive definition for a longer string. Actually, if the string can be broken into a prefix character A and the suffix string X, then the transition is going to be the following. So this is a bit confusing, so let's go to it. So you get this monster expression, okay? And I'm going to explain this monster expression shortly. The important thing when you see such a monster expression is to not panic, because you just need to slowly, break it up and understand what's going on. So let's do that. Okay, so the first stage is to observe that we don't need the parentheses, right? And now let's look on this. The first step is to compute the reachable set from Q, right? So let's R be all the states that are epsilon reachable from Q. So now we can write the delta function as this union. And again, we also omitted the parentheses because we don't need them, right? So union of a union can be written, what is this set that we are doing the double union over? So let's compute N. So this is just going to be the union over P of P in R over all the states in delta star of PA, right? Okay, so this union N is going to be all the states reachable for Q with the letter A, right? We first did the epsilon transition from P, and then we took A, and we got all the states reachable. And now that we have that, the definition becomes quite simple, right? Because now we get this, right? All the states that are reachable from Q with the letter A, now we take their transition function delta star from R, right? So for every state that is reachable with the letter A, with epsilon transition before, epsilon transition after, we look on all the states that are reachable from R and we take the reunion. So this gives us the set of unions that are reachable. And we then do the epsilon reachable of them. We do the epsilon closure of this set. And this is all the states that are reachable from Q and W, right? Now, I should say that this is not necessarily the minimal definition of this transition function, but conceptually, it's the easiest way to think about it, right? You apply epsilon transition before you move, then you move one letter, you apply epsilon transition, and then you apply again. You apply the transition function on the suffix, and then you apply epsilon transition, the outer epsilon transition, to get the closure of everything, right? So you can just think about, the automata alternate between moving on inputs and doing epsilon transitions. And you should do the epsilon transition before you start moving and after you are done moving. And if you do that, then you get a transition function. Okay, I hope this is clear, despite everything. So, and now the nice thing is that we have a short definition of what is the language of an automata NFA. We look on its transition function, and it's just all the states. We look on all the states that are reachable from S with the string W, and if this set of states includes some state that is being an accept state, then the string W is in the language. Right? So that tells us whether a string is accepted or not. This defined is accepted. This is what this definition defines. And now the language is just the union of all the, it's a set of all the accepted strings under this definition. N is just the transition function of the automata. You don't really need it. If you want, you can add it. If not, then not. It doesn't matter. Okay.